In the boundless expanse of the cosmos, we are surrounded by a seemingly infinite number of stars, each one a sun, blazing away through the vastness of space. Yet, when we look deeper into the night sky, beyond the familiar constellations and the bright celestial bodies, something extraordinary beckons us. Among the galaxies and nebulae, there exists a phenomenon so bright, so powerful, that it can be seen from billions of light years away. A brilliant flash of energy that outshines entire galaxies. These are the quasars, enigmatic objects, shimmering like cosmic beacons from the very edges of the known universe. They are far more than just sources of light. Quasars hold the key to unlocking the mysteries of the universe's infancy, offering us a rare glimpse into a time when the first galaxies and supermassive black holes were forming, a time when the universe itself was still taking shape. It all began in the 1950s when astronomers first stumbled upon something strange. Using newly developed radio telescopes, they noticed distant sources of radio waves, far too bright to be explained by stars alone. At first, these objects seemed to be merely faint, star-like points of light. But there was something about them that didn't fit with the known laws of physics. Their brilliance, their energy output, and their spectral signatures. Their energy was beyond comprehension. More than 1,000,000 times brighter than our own galaxy, the Milky Way. These peculiar, distant objects, once thought to be stars, were quickly recognized as a completely new phenomenon, an object so unusual that it required a new name, the quasi-stellar object, or quasar. For the first time in human history, we had glimpsed something so far away, so intense, it seemed to belong to another world entirely. To understand what a quasar truly is, we must first look at the very heart of these extraordinary objects, the supermassive black hole at their core. At the center of every quasar is a black hole that is millions, even billions, of times more massive than our sun. As matter, gas, dust, and even entire stars falls toward the black hole, it forms a glowing accretion disk, spiraling inwards at unimaginable speeds. This disk, heated by the intense friction between particles, becomes a furnace of light. The energy radiated is so immense that it can be seen across the universe, outshining the rest of the galaxy itself. The black hole doesn't just consume, it creates. Powerful jets of radiation shoot outward, near the speed of light, stretching vast distances into the dark void of space. But this isn't the only secret that quasars hold. They are much more than just an energy source. They are also the cosmic laboratories, where we can observe the most extreme conditions in the universe. These environments are where the rules of physics are pushed to their limits, providing us with the most direct evidence of how the universe began and evolved. Quasars are not just distant, powerful beacons. They are also a gateway to the past, offering us a glimpse into the universe's youth. Their light traveled across the cosmos when the universe was still in its infancy, just a few 100 million years after the Big Bang. Imagine, if you will, a universe still in its childhood, where the first stars and galaxies were beginning to emerge from the darkness. The universe was dense, hot, and turbulent. It wasn't until around 400 million years after the Big Bang that the first proto-galaxies began to form, and the light from the first stars began to pierce through the primordial fog. This period of time is known as the Cosmic Dawn, a time of intense creation, where the universe began to take on the structure we recognize today. But the stars and galaxies that shone in those early days were vastly different from what we see now. Quasars serve as cosmic time capsules, preserving the conditions of the universe during this primordial phase. Their light, which has traveled for billions of years, carries with it the secrets of the early universe, a glimpse into the universe's first steps toward becoming the cosmos we know today. The creation of a quasar is a dramatic and violent process. It begins with the formation of a supermassive black hole, a behemoth that takes shape in the heart of a young galaxy. The process starts with the collapse of massive gas clouds, drawing in everything around them under the influence of gravity. As these clouds compress, they heat up, and the material within them begins to spiral inward, forming the accretion disk we mentioned earlier. The sheer volume of material and energy generates a furnace of radiation, which can outshine an entire galaxy. At the same time, the black hole's gravitational forces cause the surrounding gas to move at nearly the speed of light, launching powerful jets of energy that stretch across the universe. These jets can have a profound effect on their host galaxies, helping to shape their evolution, triggering star formation, or even quenching the birth of new stars in some cases. Quasars are not just isolated phenomena. They are architects of galaxies, influencing the very fabric of the universe's large-scale structure. So how do we differentiate a quasar from other, more familiar galaxies? After all, both are objects composed of stars and interstellar material. But the difference lies in the central regions. While normal galaxies, like our own Milky Way, have relatively quiet centers, dominated by stars and nebulae, the heart of a quasar is anything but tranquil. It is powered by a supermassive black hole, an active and voracious object that pulls in surrounding matter, emitting energy on a scale so vast it overwhelms the entire galaxy around it. The telltale signature of a quasar lies in its spectral lines. The light emitted from a quasar stretches across the electromagnetic spectrum, from radio waves to X-rays. When astronomers observe a quasar's light, they notice a redshift, an elongation of the light's wavelength as it travels across an expanding universe. The greater the redshift, the more distant the quasar, and the further back in time we are looking. This shift is not just a detail. It is the window into the past, allowing us to peer into a time when the universe was young and full of mysteries waiting to be uncovered. The study of quasars has come a long way, thanks to the development of powerful observatories and space-based telescopes. Instruments like the Hubble Space Telescope, the Chandra X-ray Observatory, and the Very Large Telescope are providing us with the tools to study quasars in unprecedented detail. Every discovery brings us closer to understanding the origins of these enigmatic objects. With each new observation, we learn more about the dynamics of supermassive black holes, the evolution of galaxies, and the fundamental nature of space itself. Through the lens of a quasar, we are able to probe the earliest moments of our universe, allowing us to trace its evolution from the chaotic birth of the first galaxies to the diverse cosmos we see today. Each quasar we discover is a beacon from the past, a messenger from the universe's ancient history. These cosmic giants are not just illuminating the dark expanse of space, but also guiding us toward the answers to some of the most profound questions about our existence. How did supermassive black holes grow so large? How did galaxies form around them? What triggered the rapid expansion and evolution of the universe in its early years? The answers lie in the light of these distant quasars, and the more we study them, the closer we come to unlocking the secrets of the cosmos. And yet, for all the data we've gathered, the story of quasars is far from complete. We are still on a journey to uncover the full depth of their mystery.